Hello everyone, welcome back to our AI classroom. So in our previous videos, we have created a complete pipeline for our robot, uh, which has the distill bird classifier, which can route based on the three categories which we created: static, knowledge base, and the live data. So if I'll just repeat that. So static is something where we can get the answer directly from the model, which we have trained using GRPO, uh, using Google Colab. If it is a knowledge base, that means the data which we have put in our data ChromaDB is nothing but our vector database where we have inserted some of the questions. So that's our knowledge base. And the live, where we have in the last video we have seen how to integrate with the MCP server, and so we have created the MCP server integrated with our pipelines. so so whenever the distill word classify that it's a live data, it will make a API call to the using the MCP and fetch the data. So that is something we have done so far. But here today the most important question is, like, how do we know if the answers are getting which we are getting are correctly? So let's let me show you what do you what what do I mean when I say the answers are getting correctly. So let's try to run few of the tests and see whether we are getting the correct data or if it is hallucinating. So let's say if I ask who won the FIFA World Cup 2026. So as you can see, the distillbird is doing the correct thing. It's redirecting it to the fetching the MCP to get the live data, because it's about the current events. So here is what we know about the winner of FIFA World Cup 2026. It says Argentina and England have made it to the quarterfinals. Both the teams won their matches, fortunately. So that's correct. It does not have the information. Okay, so let's see who reached to the semi final of FIFA. Team made it to the France and Argentina. Those will face off against each other on June 2024. It's looking like the two countries had won. So if you can see the date which you are seeing on the screen, June 24 2026, it's definitely the model itself is creating this is not the right information. And also the teams that made it to the semi-final are France and Argentina. That is correct. And we don't know whether they are going to face each other, because as far as we know, that Argentina is not going to is not going to face France. Is going to face the different team. And so definitely, as you can see, this is not this is the data hallucination which model is creating by itself. So how to solve these problems? And this is pretty normal in RAG, or even in the AI world. The data is hallucinating. Now the scary part, if I try to ask this question again, and if I did not cache this information. So yeah, I have cached it, so it will just immediately reply back to the same answer. But even if I did not cache it, second time it may create the another answer which may be correct. So, and if I just hit it first time and go, I will see the kind of data is the model is giving the answer is the correct one, and I will go ahead and start thinking about the same line, that okay, France and Argentina is going to face each other in the semi-final. So this is like this is the hallucination of the data. So how do we solve this? So to solve these problems in the RAG world, we have a framework called RAGAS. RAGAS is basically RAG assessment. So how does the RAGAS or the RAG assessment works? So basically, it has multiple metrics like faithfulness, answer relevancy, context recall, and the context precision. First thing, we are going to talk about how the faithfulness works, and which is kind of like a what are the steps we are going to introduce. It includes, I'm going to show that. So what I have done is, instead of creating using the actual Raga library, I have created a very dummy faithful file, where how I will show you how exactly it works. So when how it works basically, it has three steps. The first so the steps are like, it will take verify, it will extract the answers, whatever the answers we are getting. So it asks extract the data, extract the claims. The second, it will verify the claims and calculate the faithfulness. And when I say extract the claims, so there will be a judge model. So in our case, we are using the judge model as Claude Sonnet 4.5, which is a judge model. It basically extract the claims, and when I say extract, I will show you what I mean. And then it will verify again. We are making Claude Sonnet as a judge model, so it will verify, and then we will calculate the faithfulness. The formula is like supported is divided by the number of claims. So that's the formula of faithfulness. So here is the I have a question, the prompt. So in for this dummy, to understand how faithfulness work, I have given the answer as well for the question. So the context is like a recent headline on World Cup, FIFA World Cup 2026 US. So the answer I have given the oh, so the question is, who won the World Cup recently? So I have intentionally given the answer is Senegal, and the recently. So this is the first question. The second question is, what is the weather today? As I am Columbus, Ohio, so I have given that answer. And the third question I have asked is, who reached to the semi-finals of FIFA? So Spain won against Belgium. I have given some of the myself given some answers, and that's how I am calculating based on these three steps. So first step is extract, the second step is verify, and third is claim, calculate the faithfulness. So let's see if I run this Python faithful. So who won the World Cup? So first step, it is doing, its request is going to the judge model, which is Claude. So what is doing, it's the answer which is getting, it basically extract. So when it extract means, it basically take the steps, take all the statements and split them. So Senegal recently made it to the World Cup final. The judge model said that's not in the context. That's so it's basically verifying against the context what we have in the context. I'll show you what we have in the context. So as you can see, they are not in the context, so answer is 0. So before that, let me show you one thing. What do I mean by context? So when we are creating the questions and answers, here we have the question. So who won the World Cup? We have a context. The recent headlines on FIFA World Cup 2026 kickoff across days, recorded attendance, expected group stage. So all the answers which judge model is going to verify again is based against the context. So if it does not match, we can say they are not in the context. The second question was, what's the weather? What is the weather in Ohio? So the context is weather in Columbus, 74 degrees wind, and that's kind of a same in the answer. So it matches with the context. And the third one is, who reached to semi-final? So Spain won against Belgium, and Spain beat Belgium, reached to semi-final. Marino scored the latest goal and is reached to a semi-final, favorite to win the tournament. Star player scored 5 goals. So this is it, basically checking the claims against the context. So that's what we are doing here. So Senegal recently, this was not in the context, not in the context. So all these things are not context. So the calculation, the formula was for faithfulness was like, number of context is divided by number of claims is divided by the number of context answers. So 0 is divided by 8. So yes, so it's nothing is correct, so that's why 0, number of claims are 8, so answer is faithfulness is 0. The next is what is the weather today, so it is supported, 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 so all number of supported are 4, number of claims are 4, so faithfulness is 1, that means it's accepted, is the correct answer. And who reached in FIFA semi-final? Spain won against Belgium, supported. Spain reached to a semi-final, supported. Spain in favorite, not in context, so here the formula, as per the formula, 2 is divided by 4, 0. So hallucination World Cup answer is 0, faithfulness weather answer is 1, and partially correct answer. So this is definitely not the correct answer, this is 100% correct answer, and this is something we can take it like, because it is 50-50. So that's how it is calculating the faithfulness for with using the ragas. So in the next video we will see how we are going to integrate this with actual ragas library, and where we are using multiple matrix, and we will go through with that. Thank you.